you look at those things, waves, they typically are represented as a sine wave, right? Something in this fashion. And we are given in general that this is the wave frequency, the wave amplitude, and the wavelength. And that's basically the parameters we describe in wave dynamics. And I was getting a headache. And I couldn't figure it out. I was like not able to visualize these waves. I was trying to visualize my view of the universe and to like see how the wave dynamics kind of fall into it. How does that all interact and where it all fits in? And I didn't quite understand what a wave was, and so I was trying to read up on it, and I was getting more and more confused. And eventually, I just said, "Okay, I gotta kind of go back to the basics." And so I drove my van up to Alpine Lake in Canada, where you have those turquoise Alpine Lake inside inside a mountains range, so it's very calm. And I grabbed a bunch of pebbles, and I was sitting on a branch on the side of the lake, throwing pebbles in the lake, going, "Okay, how are these waves working?" And I'm looking at these rings coming off the surface and all this, and it's kind of a simple approach, but I was kind of visualizing it, and I could see that if I took the waveform on the surface of the water and I sheared them, or if I divided them, I could see that it would generate this pattern, this waveform. But I thought, well, this is kind of an artificial way of looking at it, because, well, the rock is sinking. It hits the surface tension of water, and then it pushes the molecules out, and then this wave comes out. And I thought, well, you have to account that the rock has to sink in order for the wave to happen. So how do I account for that? And I was getting confused, and I couldn't understand it all together. And then I thought, but wait a minute, and I thought, if the rock is sinking and the wave is being produced, then it's like more like a vortex. And when I thought of that, it hit me. Oh, wait a minute. I'm thinking in 2 dimensions. You see how that flat 2-dimensional planes get you? That Euclidean flat space? Well, in this way, we think of waves as like, traces on an oscilloscope or something like that. But actually, a wave is a 3-dimensional vortex. I realized, oh my God, if this was in 3D, this would be a vortex along an axis of rotation. And it hit me, oh my God, waves are 3D things. We live in a 3D world. It's not a flat thing. Flatness does not exist. There is no such thing. That's a concept of man, not a fundamental structure of nature. Euclidean flat space are irrelevant to nature. And so I totally got it, and I thought, oh yeah. So, when you think of I looked at the sun and I thought, oh my God, I don't know how many times I thought of a waveform leaving the sun and coming towards me, doing this up and down thing. And it's like, not anything in the universe does up and down. It rotates, it spins. And so a waveform coming off the sun is a vortex that's touching me, that's hitting my eyes, that so on. And I realized that this was fundamental. That we commonly, because, and if you ask a physicist, he'll tell you, oh yeah, it's a 3D vortex, but we don't think of it that way. I mean, if he's well educated, he'll know that. No. And we don't think of it this way because it's too complex. We flatten it up so that Well, okay, but if you flatten it up, now you don't have angular momentum. You don't have the spin dynamics of the geometry of space, that generate the vortex in the first place. So I was like, oh, okay, so I'm thinking about all this, and I'm getting excited about it. And I laid back on the, I get excited, you might have noticed. And so I laid back on the side of the lake and I was looking at the sun setting behind the mountain tops, which happens quite early in Canada. And then I noticed that, well, actually late in the summer, but I noticed that the sun was going behind the mountains, and a thought came to my head, isn't it cool how we always think the sun is going behind, but actually it's the earth that's rotating? And when I thought that, something hit me. Another thing hit me. I realized, well, these waveforms, dynamics, have to do as well with motion in space. Things move not in this up and down motion. And then I thought, wait a minute. And I thought of the solar system, and it hit me. Typically, and if you have children, please, if they go to school, they're all going to get told that the solar system looks something like this. Let me try to erase this. Okay, that the solar system looks something like this. That the sun is in the middle, and the solar system, and in my school, we even had a little machine with a little thing, a little crank you spun, and the earth went around the sun with the moon and everything. And so they tell you, oh yeah, that's the sun, and then the planets go around like this in an elliptical course, and depending on the interaction of all the planets, it's either elongated or more round. Or you got all the planets like this in the solar system. Well, actually, that is absolutely incorrect. Okay? The thinking of the solar system in this matter is equivalent to thinking that the Earth is flat. The solar system does not behave that way at all. In fact, the solar system it behaves in a completely different way, since the sun is moving through space and the planets are flying around the sun, generating these huge vortices as it follows the equator of the sun. That is a completely different picture. All right? It goes from flat to spacious, to movement through space. And that makes a big difference. All of a sudden, you start to see that even planetary motions, solar motions around the galaxy, galactic motions, supercluster motions, and so on, all have this elliptical, vorticular dynamics of space. They all have this torque dynamic through space. And if you look at the Earth on this vortex, you could say that this is 2000, 2000 for instance, and this would be then 2001, and then this would be 2002, and this would be, this is extremely long distance apart. Millions and millions and millions and millions of miles apart. There's nothing in there, the planets do not come back onto their path. They don't. If they did, we most likely would have the same set of information over and over and over, like a broken record. Okay? And we'd probably get real bored. It would be like Groundhog Year, And so, what makes, and so it hit me in my head, oh my God, what makes every second, every billionth of a second different from the other, every part of the division of space-time different from the other, and why is information changing? is because we are never moving back onto the same coordinates of space-time. We're moving through space-time, gathering information through the system and feeding it back and modifying the structure of space as we move through it. So it was really an important realization. It had implication in the physics I was writing, but as well it had implications in psychology theories and stuff that, you know, I was interested in because you could, I've experienced and experimented on this since then, where if I give this visualization to somebody and I ask them in their mind's eye to move the Earth back along that vortex to an instance, to something that happened in their life that was traumatic, I'm able to get these people to go back to that moment in much more vivid and much more powerful way. And then what I ask them to do is to change their visualization of that experience from their perspective to the 180-degree perspective, like to the perspective of the person that assaulted them or whatever. And then they get a new set of information. And what I believe happens is that new set of information is encoded in that place in space-time. And so all of the rest of the information is changed from there on. And that is actually the effect of psychology, asking you to go back to an instance. But if you don't know, and I think that's where psychology could get some help from this theory, is that if you don't know the true dynamics, the fundamental mechanics of that motion through space, you're going to try to visualize it in something that's going back in time on the same record, broken record, so you can't get there. Right? But here, I've had instances where people were able to do that and solve some very, very important issues immediately. And what happens is that if they're there in present time, then all the geometry that catch up with them now opens a whole new sets of geometry for them in the future.